Question 33. The graph shows the number of bacteria, Y, at time n minutes. Initially, when n equals 0, the number of bacteria is 1,000. So part A, find the number of bacteria at 40 minutes. And we'll just have a quick look at part B, so it follows on the next page. Part B, the number of bacteria can be modelled by the equation y equals a times b to the power of n, where a and b are constants. Use the guess and check method to find, to two decimal places, an upper and lower estimate for the value of b. The upper and lower estimates must differ by 0.01. Alright, so let's go back to the graph and part A. So it says find the number of bacteria at 40 minutes. So on the x-axis here, let's locate the 40. From there, just all the way, so it'll go all the way up vertically to the graph until you strike the graph, and then project across, and you see that number of bacteria is 4,000. So all you need to do is just write down 4,000. All right, let's have a look at the next part here. So back to part B. Okay. So we have the equation y equals a times b to the power of n. Now the a represents the initial value. In other words, when n equals 0, b to the power of 0 is just 1, and therefore, a times 1 is just a. So a represents the value of y when n equals 0, sort of another way to put it. So going back to our graph, okay, so n equals 0 means that's the initial sort of starting value, the initial number of bacteria, and that's going to be 1,000. So a equals 1,000. Hence, the equation is y equals 1,000 multiplied by b to the power of n. Okay. Now what we need to do is to go back to our graph, because we need to estimate a value for b. Okay. We need to pick another point on the graph, and just pick a convenient point. It can be any point, but I might go back to the point that we initially found in part A, which was this point, 4,000 bacteria when n equals 40. So this here is a very convenient point to use. So we're going to substitute the coordinates of that point into this equation, and a bit of guess and check. Hopefully we can find a value for b, or at least narrow it down so that it's between sort of the two values, the upper and lower estimates, by 0.01. So the difference between them. All right, so what we're going to do is we're going to use, okay, so when, in fact the best way to write it is that when n equals 40, okay, y is equal to 4,000. And in fact that could be, or may be, a reason why part A is the way it is. It sort of gives you a clue that that's a very convenient point to use to help us with part B. Okay, so we have 4,000. Okay, y is equal to 1,000 times b to the power of n, or b to the power of 40. So n is 40. When n is 40, the number of bacteria is 4,000. If we divide both sides by 1,000, just to sort of clean up the algebra, we end up with 4 is equal to b to the power of 40. Now, we're probably going to need a little bit of extra space here. I like to set this up a little bit first before we use guess and check, but you could use guess and check at this point here if you like, to save a bit of space. So I need to find a value for b, so when I raise it to the power of 40, I get 4. All right, this is where you need to spend a minute, just try a few values on your calculator. So it has to be greater than 1, so I could try 1.1 to the power of 40, and we get 45, so it's clearly way too big. Okay, so we need it to equal 4. So when b equals 1.1, okay, y is equal to 45. So 1.1's way too big. Let's go back and try 1.01. That's way too small. Okay, so b equaling 1.01, y is equal to 1.49. Okay, we can try increasing that, say maybe to 1.05. Okay, we're getting closer, we're narrowing it down now. So b equaling 1.05, okay, y is equal to 7.0, okay, and so on. So at this point, we'll probably get it pretty close. We've got 1.04. In fact, why don't we try 1.03 while we're at it? Yeah, there you go. So 1.03, 1.04. So when b is equal to 1.03, y is equal to 3.26, and when b is equal to 1.04, okay, and I might just go back to my previous answer, is 4.8. Therefore, b must lie between 1.03 and 1.04.